Okay, this video is on triangles and special segments of triangles. And we're going to start out talking about triangle classification. And this just means classifying triangles either by their sides or by their angles. That's the two ways that we classify triangles. Now, classifying triangles by their sides, we have three ways that we can do this. The first type of triangle would be a scalene triangle, and this just means a triangle with no congruent sides. So, for example, if I had a triangle that had one side that was 5 centimeters and one side that was 6 centimeters and one side that was 7 centimeters, that would be a scalene triangle. None of the sides are congruent. An isosceles triangle has at least two congruent sides, and here's an example of an isosceles triangle. And you can see the hash marks on there indicate that these two sides are congruent, therefore it's isosceles. An equilateral triangle has three congruent sides, and an example of that would be that. And you can see the congruence hash marks are on all three sides, indicating that all three of those sides are congruent, therefore it's an equilateral triangle. Now, the second way of classifying triangles is by their angles, and there's three ways to do that, three different types of triangle classification by angles. The first is an acute triangle. An acute triangle has all acute angles. So let's see, if I had a triangle that looked something like this, and let's say this angle here was 50 degrees, and this angle over here was, let's say this angle here is 60 degrees, and this angle here is 70 degrees. Well, all of my angles of the triangle are acute angles. They're all less than 90 degrees, so that would be an acute triangle. Second way to classify a triangle by its angles is an obtuse triangle, and an obtuse triangle has one obtuse angle. So, an example of an obtuse triangle would be a triangle that looks like that, and say this angle is 110 degrees. Well, that triangle has one obtuse angle, therefore it's an obtuse triangle. And finally, we have a right triangle. A right triangle has one right angle, and that's an example of a right triangle. And I know it's a right triangle because it has the little perpendicular symbol in this corner angle right here. Now, a couple other examples of triangle classification. In this example right here, if we want to classify this triangle both by its angles and by its sides, then first off I notice that, well, I have a right angle here, therefore this must be a right triangle. And I also notice that it has two sides that both have the same measure, therefore it must be an isosceles triangle. So this classifies the triangle by its angles, and this classifies the triangle by its sides. So this would be a right isosceles triangle. And I could also, by the way, label this an isosceles right triangle. So the order in which I classify my triangles doesn't matter. So here's an example of another triangle, and I can see by this angle here, since it's greater than 90 degrees, this must be an obtuse triangle. And since I see that none of the sides are congruent, it must also be a scalene triangle. So this is an obtuse scalene triangle. And I've classified it by its angles and also by its sides. Now we're going to talk about special segments of a triangle, and we have four special segments of a triangle. The first one is called the median, and a median is just a segment that connects a vertex of the triangle to the midpoint of the opposite side. So let's say we want to draw a median from this vertex right here. So I want to draw a segment that connects this vertex to the midpoint of the opposite side. Well, this side down here is the side that's opposite the vertex. And if I find the midpoint of this side, let's see, it's about right there. So I just want to draw a segment that connects this vertex to the midpoint. So And there I have it. and this segment is the median of that triangle. I could also have drawn the median from this vertex to the midpoint of its opposite side, or from this vertex to the midpoint of that opposite side. Then I'd have 3 different possible medians that I could draw for any triangle. The second special segment is called an altitude, and that's just a perpendicular segment that connects a vertex to a point on the opposite side. Now, notice this word right here, perpendicular, that's very important in this definition. So if I want to draw the altitude on this triangle, and again, let me draw it from this vertex here. Now I want a perpendicular segment here that connects this vertex to a point on the opposite side. So the point on the opposite side, once I draw my segment, it's going to have to be perpendicular. So my altitude would look something like that. So I have a perpendicular segment connecting the vertex to a point on the opposite side. Now, one of the things to note about altitude is that sometimes the altitude, the actual line segment that is the altitude, sometimes it is drawn inside the triangle, as we see here. Sometimes, however, it's drawn outside the triangle. Take a look at this triangle over here, and let's look at this vertex. And let's say we want to draw the altitude on this triangle from this vertex. Well, if I try to find a line from this vertex to the opposite side that's a perpendicular segment that's perpendicular to this side, well, I can't draw one because all these lines are going to be slanted. They're going to be at an angle that's not 90 degrees. Well, the way I handle that is I just extend the side out in this direction. Now I can draw a perpendicular segment connecting this vertex to the opposite side. And this would be my altitude drawn from this vertex. All right, next we want to talk about the perpendicular bisector. Now this is a term we've already talked about in class with regard to perpendicular bisector having to do with segments. Now we're going to talk about it specifically with regard to triangles. A perpendicular bisector with regard to triangles means a segment bisector that is perpendicular to a side. So for example, let's say I'm talking about this bottom side of this triangle. I need a segment bisector perpendicular to this side. So if I'm going to bisect this side of the triangle, that means I've got to draw a line that divides this segment, that is this side of the triangle, into 2 congruent segments. So these 2 segments are going to have to be congruent. And I need my bisector to be perpendicular, and it needs to go through this point here. So my perpendicular bisector is going to look like that. Notice that my perpendicular bisector does not go through any of my vertices. And sometimes that's the case. Depending on where your perpendicular bisector happens to fall, it may or may not actually go through a vertex. Now here's a case over here. If I draw a perpendicular bisector through this side of my triangle, I've got an isosceles triangle here. Well, the midpoint of this side here, which divides this side of the triangle into 2 congruent segments. Now it turns out if I draw the perpendicular bisector to this side, that line will in fact go through the vertex of that triangle. So sometimes your perpendicular bisector goes through the vertex of a triangle, other times it doesn't. Now finally, the last special segment that we're going to talk about is an angle bisector. And again, we've already talked about angle bisectors with regard to angles. When we talked about them before, we talked about how an angle bisector is a ray that separates an angle into 2 congruent angles. And that's what we have right here. Well, since we're specifically talking about, we're calling all of these special segments, we're going to kind of modify this definition a little bit for triangles. And we're going to say an angle bisector is a ray or a segment that separates an angle into 2 congruent angles. So if I'm talking about this angle right here in my triangle, and if I want to draw a segment that divides this angle into 2 congruent angles, well, this then is my angle bisector for for this angle. And again, I could have drawn an angle bisector that bisected this angle. I could also draw an angle bisector that bisected this angle.